Good morning, my people. How have you been? Welcome back once again. My name is Ridwan. Today, as you all know that we have already started the part one, the part two, part three, and part four of these topics. That's laws of indices. So we have started since part one. We talked about the laws. Then part two, we simplified some expressions. Part three, we solved some equations. Part four, we also continue with the solving of equations. So now today, we want to solve some of these exponential what? Equations. So if you have not watched the previous videos, so you can check them. You will see part one, part two, part three. So this is the part five of that series, and you are going to enjoy it. Kindly follow me. Let's go there. So today, what are we going to do? As we all know that I used to give you many questions. I will solve some, then you will solve the last one. So I've already kept the beautiful gift I have for you today. Can you see that? That's the fourth one. So we are going to solve the first three together. Then the last one, you are going to solve that. So let's start, everybody. Let's look at this type of equation. Question one. So we have what? 2 raised to power 2x. Okay, minus 5 into bracket 2 raised to power x plus what? Plus 4 equal to 0. Every time, whenever we have this kind of equation, at least the first thing we have to put in our mind is that how to simplify that equation so that it will be able to, you'll be able to get whatever you are asked to do conveniently. For example, now we have to solve this. Solving this means we have to look for the unknown, the value of the unknown in this equation, which will make this equation to be what? To be satisfied. And as you can all see, what is the unknown that we have here? Good of you. We have x as the unknown. But x is at what? Is an exponent here. Is at the power of a particular value. So we have to find our way to make sure that we simplify this thing in such a way that we are going to get the value of x conveniently. We can use different methods, different ways, but the best approach as of now is to look at this thing very well. Of course, we cannot use any other thing apart from some of the laws of indices that we have been working with since part one of this topic. So look at this, everyone. The first one, I have 2 raised to power 2x. This is just like 2 raised to power what? X into bracket 2. If you remember one of those laws, if I want to return this one back to this, it will become x times 2. That means we come back to 2 raised to power 2x. What does that tell us? We have not changed anything. Good. Minus 5 into bracket 2 raised to power of x. Then plus 4 equal to 0. Okay? Now, don't forget that this bracket actually means multiplication, which means this one is like 5 times 2 raised to power x. Don't forget that. Now, what do you observe? I have 2 raised to power x here. I have 2 raised to power what? X here. I can make an assumption. I can say, okay, let 2 raised to power x to be equal to p. You can use anything you like. I can even use y. You can use any letter that you like, okay? So let me call it this one. You can call it anything. Let's call it equation star. Let me call it equation star, okay? So this is an assumption. Let's call it equation star. Now, what do we need to do? You will now go back to this place and replace 2 raised to power x with p. Okay? I will now say, therefore, the above equation will now become p square 2 raised to power x. We say it should be p. It will now be p raised to power 2 minus 5p, okay, plus 4 equal to 0. Wow, this is beautiful. This is a very simple quadratic equation. And when we are talking about quadratic equation, we can actually solve quadratic equation using in different ways. We can use factorization if it is factorizable. We can use completing the square. We can use quadratic formula. So we can even plot graph. We can solve with graphical method. But let's just keep it simple. So let's look at this. How do we solve quadratic equation? Of course, Let's check if this one is factorizable. How do we check? The coefficient of p squared is 1. Constant term is plus 4. If I multiply two of them, 1 times 4, that is 4. Okay? Now, after multiplying the coefficients 1 and 4 together, you will now ask, what are the values that you will multiply together that will give me minus 5, this minus 5, which is coefficient of p. And when I add them together, I will get minus 5. When I multiply them together, I will get positive 4. Again, the two values that you multiply together, you will get positive 4. But when you add them together, you will get minus 5, which is coefficient of p. And what are the values? The values are minus 1 and minus 4. Wow. What do we mean by that? If I say minus 1 multiplied by minus 4, minus times minus plus, then 1 times 4, that's 4. So I'm going to get positive 4. Do we get that? What of if I add them, minus 1 plus minus 4? It will be minus 1 plus times minus 4. So minus 1 minus 4, you owe someone 1, you owe someone 4. So the total debt is what? 5. That is minus 5. Beautiful. That means in this case, the values that we want to use now, they are what? Minus 1 and minus 4. Those are the ones that satisfy those conditions. I will now say p squared. I will now split this minus 5p into this. I will now say minus 1p. Okay, that's minus 1. Minus 4p plus 4 equals 0, because minus 1p minus 4p will give us what? Minus 5p. So we have not changed anything, okay? But mathematically, there's no need for us to put what? 1 here. So let me remove the 1. Am I communicating? Let's remove the 1. So if you don't put 1 there, it still means what? 1 is the coefficient there. So we have p squared minus p minus 4p plus 4 equals 0. Now let us factorize. I can pick it like this. The first two terms, I can bring what is common to them, p. I will now say p into bracket. What will remain here? P, then minus what? Minus 1. Then what is common here? Minus 4. I can factorize minus 4 out into what? P minus what? Minus 1. Everything equals 0. What do you observe? You know now, how do we get this thing? Every time we're supposed to be confirming whether what we are doing is right. For example, I can say p times p squared. Good. That means I have not done any wrong thing here. P times minus 1p. That is, we are just trying to open the bracket to confirm whether what our simplification is correct or not. P times minus 1, that's minus p. Okay. Then this one too, minus 4 times p, that's minus 4p. Minus times minus plus 1 times 4 times 1, that's 4. Beautiful. Everything is correct here now. Okay. Now let's go. What do? We now transfer this one to that side. We can now say, if you take these two, p minus 1 here, p minus 1 is here. We can factorize it out because it is common. I will now say p minus 1, okay, bracket into bracket. I want to factorize p minus. When you bring p minus 1 out of this one, it will remain what? P. Good. When you factorize p minus 1 out here, it will remain what? Minus 4. Beautiful. Equal to 0. Okay. And when you have something like this, mathematically, it is either p minus 1 is equal to 0 or p minus 4 equal to 0. What you are saying is, for these two things to be multiplied together to give us 0, it is either p minus 1 is 0, okay, or p minus 4 equal to what? Equal to 0. Are you with me? All right, good. Now from here, I can now say p is equal to what? To solve this simple linear equation, transfer minus 1 to this side. That's 0 plus 1. Or p is equal to what? 0 plus 4. What does that mean? P is equal to 1 or p is equal to 4. Beautiful. Everybody, we are not done yet. Do you know why? Nobody asked us to find p. But for our own conveniency, we made an assumption from this equation star. What we are actually interested in is to get the value of x, which will satisfy the original equation. I will now say that, okay, now, from equation star, we cannot get our x. What is in equation star? Rewrite it, which is 2 raised to power x is equal to p. We now say, when p is 1, don't forget we obtain two values for p. When p is 1, comma, what will you do? You now say, 2 raised to power x is equal to 1. Oh, that's beautiful. Then I have 2 raised to power x here. The value, the x I want to get is at the power of x. How can I express 1 as power of 2? Don't forget, any number raised to power 0 is what? 1. Except 0. That value must not be 0. So I can express this one as 2 raised to power of 0. Beautiful. Now let's use that law. The bases are equal, therefore the powers are equal, therefore x is what? 0. Comma. Are we together now? Okay. Let me use, okay, I can use this place now. So let me use this place. Are we following, everybody? Please kindly subscribe, share, and like. Now let's go. So we are done. We have obtained the first value of x. That's okay. Similarly, when what? When x is what? When p is what? 4. Then what do we have? I will now say 2 raised to power x is equal to what? 4. And very easy. We can express 4 as 2 raised to power 2. So we can just say 2 raised to power x is equal to what? 2 raised to power 2. As usual, the bases are equal, therefore the powers are equal. Therefore, x is equal to 2. In general, therefore, finally, x is equal to 0 or x is equal to 2. So these are the what? The solution that we have for that equation. Beautiful. Is that lovely? Nice one. So we are through with that. Let's go to the next question. Let's go to the next question. So I hope you are following, everybody. So now this second one, since we are going to implement the similar rules, so we are going to speed up a little bit. So number 2, we have what? 2 raised to power 2x plus what? 1 minus 5 into 2 raised to power of x, right? Plus what? Plus 2 equals 0. So what do we have? I can express this as 2 raised to power 2x multiplied by 2 raised to power 1. Very beautiful. Do we all know why? From the laws of indices. Okay? That means I can write this as this. How do you know? You can confirm. You can say, okay, the law of indices say, if I have the same thing here, you pick 1, 2, then we add the power 2x plus 1. That means this one, you can turn this one back to this. The same way we can turn this one back to this. Simple. That means we have not changed anything, okay? Now, I can also write this one as 2 raised to power x raised to power of 2. This one, you remember we have done something like that. Times 2. 2 raised to power 1, it is still 2, okay? Minus 5 into bracket 2 raised to power of x plus 2 equal to 0. Wow, that's lovely. Now, also, I can say, let 2 raised to power of x, because I have 2 raised to power x here, I have 2 raised to power x here. Let it be y. Okay, you can use anything, mind you. Equation star, isn't it? Now, what will I do? I can now say, therefore, the above equation will now become y squared multiplied by 2 minus 5 into bracket y plus 2 equal what? 0. Beautiful. So y squared times 2, that is 2y squared minus 5y plus 2 equal to 0. So this is a very beautiful quadratic equation as well. What do we do as well? Multiply the constant term, that's 2, multiplied by the coefficient of y squared, which is 2. 2 times 2, everybody, that's positive 4. Now, the same thing, what are the value I will multiply together to give me positive 4? When I add them together, I will get minus 5y. That is still what? Just like the one we did, minus 1, minus 4. So this one will now become 2y squared minus 1y, that's minus y, minus 4y, okay, plus 2 equal to 0. Because minus 1y minus 4y, it will still give us minus 5y. So we haven't changed anything. What do we do? As usual, we factorize. What is common here? The first two terms. Y is common. You factorize y out. What do you have here? 2y minus 1. Here, what is common? Between minus 4y and 2. I can factorize minus 2 out. Okay? Minus 2 into bracket what? Into bracket 2y minus 1 equal to 0. What does that mean? That is, if you open the bracket, you get the same thing. Y times 2y, 2y squared. 1 times minus 1 minus y. Minus 2 times 2y minus 4y. Minus 2 times minus 1 plus 2. Beautiful. We have not changed anything. So from here, what do, everybody? We factorize. Correct. So you got it. So what do? What is common here? 2y minus y is here. 2y minus y is here. So now say 2y minus 1. If I bring 2y minus 1 out from this first term, I am left with y. Beautiful. If I bring 2y minus 1 out here, I am left with minus 2. Minus 2 equal to 0. Okay? That's beautiful. What do we now have? I say 2y minus 1 equal to what? 0, or y minus 2 equal to 0. From here, 2y equal to 0 plus 1, that's 1, or y is equal to 0 plus 2, that's 2. You transfer minus 2 to this side. Okay, then from here, you have to divide both sides by 2. Y will now become 1. This one divided by coefficient of y, 2, or y is equal to 2. But don't forget, everybody, nobody asked us to find the value of y, mind you. We are interested in getting the value of x that will satisfy this equation, isn't it? So we now come back, we now go back to this, our assumption. So we now say, now from where? From equation star. What do we have in equation star? Where is it? We have 2 raised to power x equal to y. We now say, when what? Because we have obtained two values of what? Of y. So when 1 is what? 1 over 2. We now say 2 raised to power x is equal to y, which is what? 1 over 2. But don't forget, as one of those laws, I can express 1 over 2 as 2 raised to power minus 1. Beautiful. Then as usual, the bases are equal, therefore, the powers are equal. X is minus 1. Okay? Beautiful. And finally, everyone, we now have what? We now say, or when what? When y is what? 2. Then we have what? 2 raised to power x. This one equal to what? Y. So we now say 2 raised to power x equal to what? 2. Power here is x. Power of 2 here is what? 1. Because I can say 2 raised to power x equal to 2 raised to power 1. We have not changed anything. So the bases are equal. Therefore, x is equal to 1. Beautiful. X is equal to 1, or x is equal to minus 1. If you substitute to the left-hand side of that equation, so you simplify, you will get a 0, which we have at the right-hand side. Beautiful. Nice one, everyone. So let's go. Let's go to the last one for today, before you now take that fourth one, the last one, as your own beautiful gift for today. Okay? So the third one, what do we have, everyone? Number 3. So number 3, I have what? We have to solve this equation. 5 raised to power 2x, okay? Minus 5 raised to power 1 plus x, okay? Plus 6 equal what? Equal 0. What do we have? I can write it as 5 raised to power x. You know we have been doing that before. Raised to power 2. Beautiful. Minus, I can write this one as 5 raised to power what? 1 times 5 raised to power what? X. Everything plus 6 equal to 0. You understand? Because if you want to do that law of indices, I can pick one of the 5. If I pick one of the 5, it will become 5 raised by what? Oh yeah, add the power. 1 plus what? X. That means this one, we have come back to this. Beautiful. So we have not changed anything, okay? So that means we can rewrite this one as this. So let's go. It will now become what? I can even say this is 5 raised to x all square, okay? Minus 5. Okay, 5 into bracket 5 raised to power x. Because that bracket also means 5 times 5 raised to power x. So we have not changed anything. Plus 6 equal to what? 0. I have 5 raised to power x, 5 raised to power x, just like the one we did under that of 2 raised to power x. So I can say let what? 5 raised to power x to be equal to q. Let me use q now, okay? Equation what? Equation star. Can use any equation you like. Oh, me, I just like that star, okay? So let's go. I can now have, so instead of 5 raised to power x now, I have q. So substitution, q squared minus 5q plus 6 equal what? Equal 0. Beautiful. What's the constant of q, everybody? 1. What is the constant of plus 6? 1 multiplied by plus 6, that's plus 6. What are the two values you will multiply together? You will get plus 6. When you add them, you get minus 5. Beautiful, you got it. That is minus 2 and minus 3. Oh yeah, let's test. Minus 2 times minus 3, minus times minus plus 2 times 3, 6. Correct. Now minus 2 plus minus, that's minus 2 plus minus 3, that's minus 2 plus times minus minus 3. So minus 2 minus 3, that's minus 5. Which is this? Lovely. That means the two values we are going to use now, they are what? They are minus 2 and what? And minus 3. Okay? I will now write this one as q squared minus 2q minus 3q. Can you see? Minus 2 minus 3, that's minus 5. Okay? Then plus 6 equal to what? Equal to 0. Now I can simplify. I can factorize the first two terms. Q is common. I will bring it out. It will remain q minus what? 2. Then minus 3 into bracket q minus what? 2 equal to 0. You can even check. Q times q, q squared. Q times minus 2 minus 2q. Minus 3 times q minus 3q. Minus 3 times minus 2 plus 6. Wow! So we have not changed anything. So as we are progressing, as we are moving, we are even cross-checking that, okay, oh, I have not done any wrong thing. Okay, so let's go. From here, as usual, what do we have in common? Q minus 2. Oh, yeah, let's factorize. We now have q minus 2 into bracket what? When you bring q minus 2 out here, we are left with what? Q. When you bring q minus 2 out here, we are left with what? Minus 3 equal what? 0. Good. Q minus 2 equal what? 0, or q minus 3 equal 0. Am I communicating? So q is what? Transfer 2 to this side, that's 0 plus 2. Q becomes 2. Or q is what? Transfer minus 3 to this side, 0 plus 3. That is what? 3. So q is 2 or q is 3. Wow, that's lovely. What do we now say? Then we can now say that we can now go back to this 5 raised to power x equal to what? But we can now say from where? Equals a star. From 5 raised to power x equal to q, comma. Now say when what? When q is what? 2. Okay, what do we say? We now say 5 raised to power of x is equal to 2. Okay? But everybody, wow, let's look at this. This is beautiful. There's no way we can express 2. There's no way we can express 5 as power of, we can't express 2 as 5 raised to power something. It's not possible, isn't it? In this case, what can we do? You now say, okay, whenever we have this type of problem, what do? We are going to add logarithm of base 5 because I want to get value of x, and x is at the power of 5. So I can add log to base 5. I can say add log to base 5, log of base 5 to both sides. Okay? Although I will still treat logarithms, but we also have some laws of logarithms as well, but we can just use this one for now because of what this equation gave us. So what are we going to have? We now say logarithm to base 5 of 5 raised to power x equal to logarithm of 2 to base 5. Now, one of the law of logarithm is that when you have something like this, bring this x to the back. It will now become x multiplied by logarithm of 5 base 5. Okay? 5. This is 5 base 5 equal to what? Logarithm of 2 base 5. Okay? And log anything base that same thing is 1. So log 5 base 1 is 1. So log 5 base 5, 1. 1 times x. Therefore, x is equal to log 2 base 5. That is the first result. Okay? And finally, what do we have? So we now have, now say, or when what? When q is what? Is 3. Don't forget, we obtain q is 2 or q is 3. So when q is 3, what do we get? We now say, therefore, 5 raised to power what? 5 raised to power x equal to what? 3. Are you with me? The same thing. There's no way we can express 3 as 5 raised to power something. So we also say, okay, add logarithm to base 5, logarithm of base 5 to both sides, okay? Both sides. We now have log 5 raised to power x base 5 equal to log 3 base 5. X will come to the back. Now become x log what? Log 5 base 5 equal to log 3 base 5. Log 5 base 5 will give us what? 1. So 1 times, that is x into bracket 1. That's x times 1, okay, equal to log 3 base 5. So x is equal to what? Log 3 base 5. So we can leave it like that. We can also say that this is going to be log 3 all over log 5. Then we can find log 3 base 10 divided by log 5. We can still simplify for that, but at least once you get here, you have done well. Wow! Welcome back, everybody. That's lovely, that's beautiful, that's cool, and that's interesting. So this beautiful gift is for you. Make sure you attempt this, make sure you do that. So kindly subscribe, don't forget to subscribe so that when I hope for that videos, then you'll be notified and it will be of benefits to you. And make sure you share it with your friends as well. They will find it, you find all these things, they will find them interesting and you'll find them useful. And don't forget, I'm still uploading classes on Python and Java as well. So stay tuned.